Imagine a country completely transforming its destiny, not just down here on the ground, but way up in the cosmos. Welcome to today's Explainer. We're diving into a premium strategic briefing on India's space power revolution. Now, we're not just going to be geeking out over rockets today. We're actually analyzing how a nation integrates orbital technology to fundamentally shift global geopolitics, economic power, and even everyday terrestrial infrastructure.
But before we get swept up in all the massive triumphs, I want you to consider this massive paradox. How on Earth, or rather off Earth, does a nation literally land on the moon, pulling off some of the most complex orbital mechanics in human history, but then capture only 2 to 3% of the global space economy? It's wild, right? Well, understanding this exact gap is absolutely crucial if we want to grasp the future of global space competition.
So, to decode all of this, here is our roadmap for today's briefing. 1. The space power paradox. 2. India's orbiting achievements. 3. Strategic and economic impact. 4. The hidden gravitational pulls. And 5. Future trajectory and revision. All right, let's dive right in.
Part 1. The space power paradox, from launchpad to global competitor. To really understand this paradox, we need to look at the massive shift that's currently underway. You see, the Indian Space Research Organization, ISRO, is no longer just your standard run-of-the-mill satellite launching agency. It's rapidly evolved into a full-blown planetary exploration powerhouse, and it's gearing up to be a major global competitor.
Which brings us to Part 2, India's orbiting achievements, mastery, innovation, and exploration. This whole evolution into a global powerhouse, it's completely defined by an incredibly rapid mastery of innovation and deep space exploration. Now, look at this rapid evolution of capabilities. We're not just throwing random dates around here. In 2023, India pulled off the Chandrayaan-3 lunar landing. That made them one of the very few nations to conquer the harsh lunar South Pole. But honestly, that was just the warm-up. That exact same year, they launched the Aditya L1 solar mission to literally study space weather. And most recently, they kicked off the SADI-X docking mission. So you can see this clear, aggressive trajectory from mastering the moon to tackling much deeper planetary sciences and complex orbital mechanics.
And that SpaceX mission, it brilliantly shows us what the future holds. SpaceX, which stands for Space Docking Experiment, is this highly advanced mission where two separate satellites, a chaser and a target, perform autonomous in-orbit docking maneuvers. Now, why is this such a game changer? Because it isn't just a simple test. It's the foundational building block for future on-orbit satellite servicing and the real ultimate goal, assembling an actual independent space station.
Now, the driving force behind all this massive expansion is a staggering number: $14 billion. That is the projected value of the global small satellite market by the year 2031. It's huge. So, to capture a slice of that booming demand, India developed a Small Satellite Launch Vehicle, or SSLV. By offering really cost-effective launch services, the SSLV is suddenly allowing universities, startups, and international clients to launch their own experimental nanosatellites. It's positioning India as a fierce competitor in the global commercial market.
But here's the thing, the innovation isn't just happening out on the launch pad, it's happening in the boardroom too. In 2024, a 10 billion rupee fund was approved specifically to back space startups. Think of this as a massive ecosystem catalyst. It's already fueling over 40 private companies. By democratizing space innovation, this fund is basically transitioning India from having a purely state-run space program into having a really dynamic, private sector-driven economy. And that means massive employment and major deep tech growth.
Part 3. Strategic and economic impact, grounding the space vision. Okay, so we've seen all the shiny hardware up in orbit, but to truly ground this vision, we've got to ask the so what question. What real-world, everyday terrestrial problems are actually being solved here?
Because space tech doesn't exist in a vacuum, pun intended. It operates as this interconnected system that drives real national progress. Let's break it down. In the social and agriculture sector, satellite data powers the PM Kisan scheme for real-time crop monitoring, while the Bhuvan Geoportal handles disaster management on the ground. Over in security and defense, satellites like GSAT-7 and the upgraded Navix navigation system provide critical strategic surveillance. That means less reliance on foreign GPS and a huge win for data sovereignty. And finally, on the global stage, partnerships like the NASAR satellite with NASA and signing the Artemis Accords seriously boost India's soft power when it comes to climate science and responsible space governance. It's a completely holistic ecosystem.
Part 4. The hidden gravitational pulls, vulnerabilities, and limitations. However, despite all these incredible, interconnected systems, there are hidden gravitational pulls, real, glaring weaknesses that are holding back India's total space dominance.
So let's go back to that paradox we talked about at the very beginning. Look at this. Despite having incredibly cost-effective capabilities and making massive technological leaps, India's share of the global space economy is sitting at a mere 3%. The rest of the world holds 97%. Why? Well, because simply being technologically capable doesn't automatically equal commercial or strategic dominance.
A big part of this comes down to how different capabilities get prioritized. We see this really stark contrast between India's civilian triumphs and its defense vulnerabilities. On one hand, India has been amazingly successful at using satellites for socio-economic benefits. But on the other hand, its defense posture in space is still pretty underdeveloped. With global powers increasingly militarizing space, lacking robust anti-satellite weapons and space-based early warning systems leaves all that critical orbital infrastructure we just talked about dangerously vulnerable to new security threats.
And underlying all of this is a pretty vicious systemic cycle. It all starts with modest budget allocations. Tight finances mean India still relies way too heavily on foreign suppliers for critical tech, things like advanced sensors and propulsion systems. And because the domestic deep tech infrastructure isn't fully funded, it creates a massive brain drain. Top-tier, highly skilled professionals end up migrating to global space giants who can offer better opportunities. Ultimately, this gap in talent and resources leads to delays in major milestones like the Gaganyaan human spaceflight mission, which still relies on foreign life support systems.
On top of that, you have regulatory bottlenecks. Look, democratizing the sector was definitely a step in the right direction, but the Indian space policy of 2023 still doesn't adequately address things like liability, intellectual property rights, or dispute resolution mechanisms. If you're a private investor or a big international commercial partner, those legal blind spots are absolutely terrifying. This lack of a rock-solid regulatory framework actively scares away the massive capital that's needed to grow that tiny 3% market share. Finally, we can't ignore the environmental impact. As launch frequencies and satellite deployments keep ramping up, it's simultaneously fueling the growing crisis of space debris. Defunct satellites pose severe, real-time risks to active, operational assets in orbit. Now, there's definitely a strong push for sustainability and adherence to the Artemis Accords, but the physical reality of all that junk in space remains a huge, pressing challenge, both domestically and globally.
Part 5. Future Trajectory and Revision. Charting the course to 2035. So, we've seen the triumphs, and we've unpacked the hidden vulnerabilities. Where is this whole trajectory heading by the year 2035?
Let's zoom out and look at how all of this builds over the next decade, because the roadmap is incredibly ambitious. By 2025, the major goal is to finally execute the Gaganyaan human spaceflight mission. Shortly after that, the Shukriyan-1 mission aims to head off and explore Venus, pushing Indian tech even deeper into interplanetary science. But the ultimate strategic anchor? That's set for 2035, the establishment of an independent national space station. Literally every technology we've discussed today, especially that spa deck stocking maneuver, is a deliberate stepping stone to that 2035 milestone.
To really master everything we've covered, let's run this entire briefing through an analytical framework. Why is India doing this? To drive self-reliance and solve massive socio-economic challenges on the ground. What are the main mechanisms? Game-changing innovations like the SSLV, SpideX, Navik, and Chandrayaan. The impact? It heavily boosts soft power, revolutionizes agriculture through tools like Bhuvan, and completely ignites a startup economy. But the limitations are the gravity holding it all back. That tiny 3% market share, reliance on foreign tech, and a really tough brain drain. That is the complete, interconnected, big picture.
All right, let's do a super quick 30-second revision recap of your essential takeaways. Remember, SpideX is the autonomous docking tech that is literally paving the way for the 2035 space station. The SSLVs and that 10 billion rupee fund, they are democratizing the private startup ecosystem. Down on Earth, the Bhuvan geoportal and Navik are absolutely critical for data sovereignty. But never forget the core paradox. Massive orbital achievements contrasted by just a 2 to 3% market share. And the major threats keeping that number low are brain drain, legal policy gaps, and the rising militarization of space.
Which leaves us with this final critical thought. India has absolutely definitively proven that it has the technical chops to reach the stars. But can it bridge the massive gap between its incredible lunar triumphs and its very real commercial, legal, and strategic vulnerabilities? Solving that specific equation is exactly what will determine the true geopolitics of the next space age. Thanks so much for joining me for this explainer. Keep questioning the big picture, and I'll catch you in the next briefing.